Imagine standing at the edge of existence itself. 13.8 billion years ago, our universe erupted into being from conditions so extreme that our most fundamental laws of physics simply collapse. But what if I told you that scientists have found ways to peer beyond this cosmic horizon into realms where time didn't tick, space didn't exist, and reality as we know it becomes meaningless? Welcome to the most profound mystery in science: what existed before the Big Bang? This isn't just idle curiosity. The answer could reshape everything we think we know about existence, consciousness, and our place in the cosmic order. When physics breaks down, scientists call it T=0, the moment when our universe began. But this innocent notation masks something extraordinary. It represents the exact point where our best theories hit an impenetrable wall. Einstein's equations, which describe gravity and space-time with stunning precision everywhere else, produce infinities and impossible results when applied to this primordial moment. It's as if reality itself posts a do not enter sign written in the language of mathematics. Before T=0, there was no stage for any cosmic drama to unfold. No dimensions to measure, no space to fill, no time to pass. We're attempting to describe something using concepts that only make sense after the moment we're trying to examine. It's like trying to describe the color of something that has never reflected light in a place where light itself cannot exist. Yet modern physics suggests something profound was happening in this impossible realm, the quantum foam revelation. Even in what we call empty space, something remarkable occurs. The quantum vacuum isn't truly empty, it seethes with activity at the smallest scales imaginable. Virtual particles pop into existence, live for inconceivably brief moments, then vanish again. This happens trillions of times per second in every cubic inch of space around you right now. These aren't just theoretical curiosities. Scientists can measure their effects through phenomena like the Casimir effect, where two metal plates placed extremely close together in a vacuum experience a measurable force from quantum fluctuations. Empty space literally exerts pressure. Here's where it gets mind-bending. If our entire universe could emerge from a quantum fluctuation, what was the quantum vacuum fluctuating within? This pushes us toward even deeper questions about layers of reality beneath what we can observe. The leading theory suggests our cosmos began as buoyant to one such quantum fluctuation. But instead of vanishing like virtual particles normally do, it inflated faster than light itself, creating space as it expanded. Think of a soap bubble forming on perfectly still water, except the water doesn't exist, the surface doesn't exist, and somehow the bubble creates both as it grows. The multiverse implication. If quantum fluctuations created our universe, physics suggests they wouldn't stop there. The same processes that birthed our cosmos should be creating others constantly, an infinite cosmic ocean where every possible wave eventually forms. This isn't science fiction speculation. It emerges naturally from our best mathematical descriptions of quantum mechanics and cosmic When you solve the equations governing the quantum vacuum, infinite universe creation falls out as an inevitable consequence. Picture an eternal cosmic sea where soap bubbles form continuously on the surface. Each bubble represents a complete universe with its own Big Bang, its own space and time, and its own unique physical properties. Some might have stronger. Most would be sterile wastelands, but a few might harbor forms of life we cannot imagine. The implications are staggering. If infinite universes exist, then every possible variation of reality exists somewhere. There's a universe where dinosaurs never went extinct, where gravity repels instead of attracts, where you became an astronaut instead of reading this script. These aren't fantasies, they're mathematical necessities in an infinite multiverse, the cyclic alternative. But what if our Big Bang wasn't the beginning but the latest? Restart in an eternal cycle. Some physicists propose that our universe follows a pattern of expansion, collapse, and rebirth, like a cosmic phoenix that dies in flames every trillion years only to be reborn from its own ashes. In this model, the Big Bang wasn't creation from nothing, but transformation from something that came before. Our universe expands for billions of years, but eventually the expansion slows, stops, and reverses. Gravity wins the ultimate battle, pulling everything back together in a big crunch. But here's the twist. Instead of ending in destruction, the Big Crunch becomes a new Big Bang. The universe bounces back from maximum compression like a cosmic trampoline, launching into a new cycle of expansion. This cyclic model solves several puzzles that plague traditional Big Bang theory. It explains why our universe appears so uniform without requiring incredibly rapid inflation. It also eliminates the uncomfortable question of what caused the Big Bang, because there was no ultimate beginning, just endless cycles. Each cycle might be slightly different, with small variations accumulating over cosmic generations. Perhaps consciousness and intelligence evolve further in each iteration as information somehow carries over from one universal hidden dimensions and colliding brains. Reality might have dimensions you cannot see, touch, or directly experience. According to string theory, our familiar 3 dimensions of space plus 1 of time might actually be 0.4 dimensions unfolded from a reality containing 10 or 11 total dimensions. These extra dimensions aren't empty space, they're dynamic, shape-shifting arenas where the fundamental forces of nature play out. The strength of gravity, electromagnetism, and nuclear forces in our familiar dimensions depends on how these hidden dimensions are curved and twisted. String theory suggests the Big Bang might have been triggered by collisions between higher dimensional objects called brains. Our entire universe could be a 3-dimensional membrane floating in higher dimensional space. When 2 brains collide, the impact releases enormous energy that looks like a big bang from our perspective inside one of the brains. This model explains several mysteries about our universe's beginning without requiring faster than light inflation or creation from absolute nothing. The brains themselves existed before the collision, making our Big Bang a transition from one state to another rather than creation from nothing. The information paradox. Every particle in your body, every atom in every star, every quantum state in every galaxy contains information. But where did all this information come from originally? Traditional physics treats information as something encoded into pre-existing matter and energy, but quantum mechanics reveals something strange. Information itself might be more fundamental than the matter and energy that carry it. This creates a paradox. If our universe began from quantum fluctuations in empty space, where did the vast information content of those fluctuations? Empty space shouldn't contain the cosmic libraries of data needed to specify billions of galaxies. The holographic principle offers a mind-bending solution. It suggests that all information in a 3-dimensional region can be encoded on its 2-dimensional boundary like a hologram containing a complete 3D image on a flat surface. Applied to our universe, this means all the information in our cosmos might be encoded on a distant boundary at the cosmic horizon. We could be living inside a cosmic hologram without knowing it. The consciousness connection. Here's where things become truly strange. Quantum mechanics tells us that particles exist in multiple states simultaneously until observed. The act of observation literally transforms quantum possibilities into definite realities. But this raises a profound question. If observation creates reality, what observed the universe before conscious beings evolved? How could the cosmos exist for billions of years before minds appeared to collapse quantum possibilities into definite states? Some physicists propose that consciousness itself might be fundamental to the cosmos, not something that emerged from complex matter, but something present from the very beginning. The Big Bang wouldn't just be the creation of matter and energy, but the first moment when cosmic consciousness began observing itself. In this view, what existed before the Big Bang was pure consciousness without content, infinite potential awareness with nothing yet to be aware of. The Big Bang represents the moment when consciousness began to observe itself, creating space, time, and matter through self-observation. If consciousness creates reality through observation, then your consciousness doesn't just observe the universe, it participates in creating it moment by moment through every observation you make. The mathematical universe. What if reality is literally made of mathematics? This isn't metaphor, it's a serious proposal that mathematical existence and physical existence are identical. Every electron, photon, and quantum field would actually be mathematical objects that have achieved sufficient complexity to interact with themselves. If our universe is a mathematical structure, then every possible mathematical structure should exist as a physical universe. There would be universes based on different geometries, different physical constants, different logical systems. Our cosmos happens to be described by the particular mathematics we observe. From this perspective, the Big Bang wasn't the creation of matter from nothing. It was the moment when a particular mathematical structure became complex enough to support conscious observers. You're not a biological creature observing mathematics. You're a mathematical pattern that has achieved self-awareness, the dark energy mystery. 70% of our universe consists of dark energy, a mysterious force causing cosmic expansion to accelerate. This energy shouldn't exist according to our understanding of physics, yet it's tearing our universe apart. When physicists calculate how much vacuum energy empty space should contain, they get a number 10 to the power of 120 times larger than what we observe. This isn't a small error, it's the worst prediction in the history of science. If quantum mechanics were right about vacuum energy, our universe should expand so violently that atoms couldn't form. The fact that we exist means the universe has somehow tuned its vacuum energy to a value incredibly close to zero, but not exactly zero. This fine-tuning is so precise it seems impossible by chance, like balancing a pencil on its point for billions of years, while earthquakes shake the table. Dark energy might be fossil energy from cosmic inflation, the rapid expansion that created our universe. A tiny remnant of the inflating field might still permeate space, providing the gentle push accelerating expansion today. It could be the dying breath of the force that created our cosmos, still echoing through space after 14 billion years. The fine-tuning problem. The forces governing reality are balanced so precisely that changing any one by even a tiny amount would make stars impossible, atoms unstable, or complexity completely forbidden. Consider gravity. If it were slightly stronger, stars would burn out in millions rather than billions of years, never giving life time to evolve. If slightly weaker, stars couldn't form because gas clouds couldn't collapse under their own weight. The electromagnetic force shows similar precision. Make it stronger, and electrons bind so tightly to nuclei that chemistry becomes impossible. Make it weaker, and atoms fall apart. The strong nuclear force is tuned even more precisely. Change it by 5% in either direction and you eliminate carbon or oxygen from the universe, making the chemistry of life impossible. The odds of all these constants randomly falling within ranges that allow complexity are essentially zero. It's like throwing a dart from a million miles away and hitting a target the size of a single atom. This fine-tuning forces uncomfortable questions. Did someone set these constants deliberately? The multiverse hypothesis suggests infinite universes exist with random constants. We observe a fine-tuned universe because we couldn't exist in any other type. Parallel universe collisions. Our universe might be colliding with parallel realities right now. According to eternal inflation theory, our cosmos is one bubble in infinite foam of realities. Most bubble universes expand away from each other faster than light, making contact impossible. But occasionally, two bubbles might form close enough that their boundaries touch. When universe boundaries collide, they interact through quantum fields, releasing energy that appears as circular patterns in the cosmic microwave background radiation, like cosmic bruises marking where another reality touched ours. Several research teams claim to have found such patterns, though other scientists dispute these findings. The signatures are so subtle they're difficult. We might already have evidence of parallel universe collisions, but we can't be certain yet. If parallel universe collisions are real, they might exchange information across boundaries. Quantum fields could carry data from one universe to another, creating interdimensional communication. Your consciousness might occasionally receive echoes from parallel versions of yourself in nearby universes that briefly touched ours. The holographic reality. Your entire reality might be a projection from a distant boundary. According to the holographic principle, all information in our three-dimensional world might be encoded on a two-dimensional surface billions of light years away. This emerged from black hole physics, where scientists discovered that information falling into black holes gets encoded on their surfaces rather than disappearing. If this works for black holes, it might work for the entire universe. The timeless realm. Time might not exist at the most fundamental level. At the deepest level of reality, all moments might exist simultaneously in a timeless realm, with consciousness creating the illusion of temporal flow by experiencing these moments in sequence. Think of a movie on film. Individual frames exist simultaneously, but playing them in sequence creates the illusion. Similarly, all moments in universal history might exist simultaneously, with consciousness creating temporal experience through information integration. Einstein's relativity treats time as just another dimension. Past, present, and future all exist equally in the block universe. Your birth, death, and every moment between exist simultaneously in four-dimensional space. Quantum mechanics suggests something even more radical. At quantum levels, events don't happen in definite sequence until observed. The quantum universe exists in timeless realm of pure possibility until consciousness collapses possibilities into experience sequences. The observer effect. Every time you observe something, you might be participating in the most fundamental process. In quantum mechanics, particles exist in multiple states simultaneously until observed, but nobody understands how. Observation causes this transformation. When you look at a JUT quantum system, you don't just discover what was already there, you participate in deciding what becomes real. The famous double-slit experiment demonstrates this. Electrons through two slits simultaneously, creating interference patterns proving they went through both. But observing which slit eliminates the interference, as if your future observation reached backward to determine the electron's past behavior. If this applies to the entire universe, the cosmos might exist in quantum superposition until conscious observers collapse possibilities into. Your consciousness might actively select which version of universal history becomes real through every observation you make. The information conservation principle. Everything that ever happens might be recorded forever in reality's fabric. Every thought, every quantum interaction creates permanent records that persist long after stars die. Information can never be destroyed. When you burn a book, the information doesn't vanish. It gets encoded in smoke particles, ash fragments, and electromagnetic radiation. In principle, tracking every particle could reconstruct the original text perfectly. If information conservation is absolute, then what existed before the Big Bang still exists in our universe's quantum information structure. The pre-pad, Big Bang state was transformed into our spacetime's initial conditions rather than destroyed. Advanced civilizations might develop technologies for reading cosmic information records, allowing them to observe the pre-Big Bang universe directly. They might discover our cosmos emerged from information patterns of a previous universe that completed its own evolutionary cycle. The ultimate. In the end, asking what existed before the Big Bang might be like asking what's north of the North Pole, a question that dissolves when we understand spacetime's true nature. Yet our exploration reveals profound connections between mind and cosmos, possibility and actuality. Perhaps the most startling discovery is that consciousness might not be an accidental byproduct of evolution, but a fundamental participant in creating reality itself. If awareness plays a role in quantum measurement, then every conscious moment might be a creative act helping determine which reality exists. The ultimate answer to what existed before the Big Bang might only come from conscious beings who survived to time's end and discovered their role in cosmic creation. Until then, we continue exploring the mystery, knowing that every question we ask participates in the ongoing creation of reality itself. We are the universe becoming aware of itself, asking questions about its own origin and destiny. In seeking to understand what came before, we participate in the eternal dance between something and nothing, between possibility and actuality, between the questions consciousness asks and the reality it helps create. The eternal mystery and in our place within it. The cosmos began in mystery and continues in wonder. But perhaps the most profound realization from our journey through these mind-bending possibilities is this: we are not separate observers looking in from the outside. No. We are the universe examining itself, consciousness emerging from the very fabric of reality to ask questions about its own nature and origin. Think about the extraordinary chain of events that led to this moment. If the multiverse theory is correct, infinite universes bubble into existence constantly, most of them sterile and lifeless. Yet somehow, in this particular cosmic bubble, conditions aligned with impossible precision to allow not just matter and energy to exist, but complexity, chemistry, biology, and ultimately consciousness itself. You are made of atoms forged in the hearts of dying stars, arranged in patterns complex enough to contemplate the stars themselves. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar furnaces billions of years ago. You are literally star stuff that has learned to think, to wonder, to search for meaning in the vastness of space and time, but it goes deeper than that. If consciousness plays a fundamental role in quantum mechanics, if observation truly helps collapse possibilities into realities, then every moment of your awareness participates in the ongoing creation of the universe. Every time you look up at the night sky, every time you contemplate these cosmic mysteries, you're not just passively observing. You're actively engaged in the process by which reality comes into being. Consider the implications. Right now, as you process these words, quantum fields are fluctuating throughout your body. Virtual particles are appearing and disappearing in the space between your atoms. Your brain, that 3-pound universe of neurons and synapses, is processing information in ways that might genuinely influence which version of reality manifests from the quantum foam of possibilities. If the cyclic universe model is correct, we're living in just one chapter of an eternal story, a cosmic novel that has been writing and rewriting itself for infinite cycles, each iteration building upon the last. The thoughts you're having right now might carry forward into future cycles, contributing to the evolution of consciousness across cosmic generations. If we exist in a holographic universe, then the boundary between self and cosmos dissolves entirely. The information that constitutes your thoughts and memories might be encoded on the same distant surface that contains the information for every galaxy, every star, every possible future. You are not in the universe, you are the universe experiencing itself subjectively from one particular vantage point. The mathematical universe hypothesis suggests something even more stunning. You are not made of matter observing mathematics, but rather mathematics that has become self-aware. Every emotion you feel, every decision you make, every creative insight that emerges in your mind, all of it is pure mathematics experiencing itself from the inside. These aren't just abstract philosophical speculations. They emerge from humanity's most successful theories about the nature of reality. Quantum mechanics, general relativity, thermodynamics, information theory, our best scientific understanding of the universe points toward conclusions that would have been dismissed as mysticism just centuries ago. Yet here's what makes our quest to understand what came before the Big Bang so remarkable: we may never find a final answer. The very nature of the question might be unanswerable using concepts like causation, time, and existence that only make sense after the moment we're trying to examine. But that doesn't diminish the value of asking. In pushing against the boundaries of the knowable, we've discovered that reality is far stranger, far more interconnected, and far more beautiful than we ever imagined. We've learned that consciousness might not be a cosmic accident, but a fundamental feature of existence itself. We've glimpsed the possibility that mind and matter, observer and observed, something and nothing, are not separate phenomena but complementary aspects of a deeper unity. The ultimate irony is this: in seeking to understand what came before everything, we've discovered that we might be intimately connected to that primordial mystery. If consciousness is fundamental, if observation creates reality, if information is conserved across cosmic cycles, then the awareness you're experiencing right now might be directly connected to whatever process gave birth to our universe. In the end, what existed before the Big Bang might be less important than the fact that beings like us emerged who care enough to ask. The universe somehow gave rise to observers capable of contemplating their own cosmic origins. Whether through random chance, fundamental necessity, or some deeper principle we don't yet understand, the cosmos has become self-aware. That may be the most remarkable fact of all. In a universe that began in unimaginable simplicity, complexity emerged that can contemplate its own beginning. In asking what came before the Big Bang, we participate in the most profound activity in all of existence, the universe seeking to understand itself. The mystery remains, the wonder continues, and consciousness, that most precious and puzzling phenomenon in all of reality, keeps asking questions that push the boundaries of existence itself. We are the cosmos awakening to its own mystery. We are the questions the universe asks about itself. We are the eyes through which infinity contemplates infinity. The journey of discovery never ends, and with each step, both the mystery deepens and our appreciation for the sheer improbability and beauty of existence grows. What existed before the Big Bang remains the ultimate frontier not just of science, but of existence itself. And we, conscious beings born from stellar fire and quantum foam, continue to explore that frontier with every thought, every observation, every moment of wonder at the magnificent mystery in which we find ourselves embedded. The cosmos began in wonder, and through us, it seeks to understand itself.